Okay, so like I said, today we're going to be learning about compound inequalities. You guys should all have page 18 in your notebook titled and dated, right? But everyone should have one of these pink sheets. This is what we're going to be taking notes on. And then we're going to, like, put this into our notebook stapled in when we're done, okay? So, what is a compound inequality? It's kind of like two inequalities in one, okay? So, if you look at this first one, it's kind of confusing, right? Because there's two inequality signs here. Do you guys see that? Okay, so with a compound inequality, like, think of it as being almost like two regular inequalities that are kind of like sharing some common parts. Okay, if I just had this, would you guys know how to solve that? Yeah, you would, right? When you know how to solve that, what would you do first? Get rid of 5 or 7? 7, right? Now, what if you had just this? What would you get rid of first? 7, right? So what we're doing here is we're basically kind of like solving two inequalities at once. So what you guys are going to do is you're going to draw a line through both inequality symbols that you have. And you guys told me that if you were solving this, your very first step would be getting rid of 7, right? So we're going to go ahead and we're going to subtract 7 from this part here. But now instead of having like two sides, we basically have 3 sides, right? We have this side, and the middle, okay? So we're going to subtract 7 from all sides, okay? All right, so when we do that, what's 32 take away 7? 25 is less than, what's left in the middle? 5a, okay, which is less than, what's left on the right side? 30. Okay. All right, so now, what if I just had this? What would your next step be? Divide. What if I just had like this? What would your next step be? Divide by 5, right? So we're still going to do that same thing that we would do normally. So let's divide by 5, but we're going to do it to every single part, the left side, the middle, and the right side. Okay, so what's 25 divided by 5?
5.
Then I just get A, and then over here I get 6. Okay, now, the instructions told us that we're going to solve and graph each compound inequality. So once the variable is by itself, I've solved it. Okay, so this is solved. And what this inequality says is it says the values of A are in between 5 and 6. Okay, the values of A are less than 6, but 5 is smaller than A, right? So A has to be bigger than 5. So it's telling us that the values of A are in between 5 and 6. So let's go ahead and draw a number line so that we can graph our solution. Our solution was this compound inequality, that the values of A are between 5 and 6. So I'm going to go ahead and draw a number line. When I draw my number line, I want to make sure that both of these numbers are included. It's not that hard because they're pretty close together, right? So okay, now when I go to graph this, I'm going to check and see what kind of circle I should be putting. So when I go to graph my circle that goes on 5, open or close circle? Open. Okay, when I go to graph my circle that's on 6, open or close circle? Open. Now, because the variable is smaller than 6 but bigger than 5, the solutions are just the points in between 5 and 6. Okay, so that would be like any fractional or decimal values in between 5 and 6, right? So 5's not a solution, 6 is not a solution, but 5.1, 5.2, 5.3, all the way up to 5.9, 5.9999999. Those are all solutions. Does that make sense? It's all the fractional values in between 5 and 6 will satisfy this inequality, making it true. Okay? All right, are there questions on that one? On how we did that? Are there questions on how we graphed it? Okay. All right. So, let's go ahead and take a look at number 2. What do you guys notice is different about number 2? There's the word or, right? So, when there's this word or, this means that we're going to graph this inequality and this inequality onto the same number line, and the solution, the points that are solutions, are either from this one or this one. Okay? So, here's what we're going to do. We're going to take this first inequality, we're going to solve it. We're going to take this second inequality, solve it. Then we're going to graph what we get onto the number line. Okay? So, how would you go about solving the first inequality? What would you do? Multiply both sides by 7. Okay, so let's multiply. Okay, we get b is less than 0. Okay, now let's take a look at the second inequality. Okay, for the second one, how would I solve that one? Divide by what number? -5. So I'm going to divide by -5 on both sides. Okay. When I do that, remember, I just divided by a negative on both sides. So what happens to the inequality symbol? Changes directions. Okay, what's -40 divided by -5? +8. Okay. So here is my solution. B is less than 0 or B is greater than 8. All right. What's that? Okay. So are there questions on how we came up with this? We're all okay on that? Okay, so now let's go ahead and graph our solution. Okay. So let's draw a number line. We want to make sure our number line has 0 all the way to 8 at least. Okay, I'm going to... Is it okay with you guys if I count my graph by 2s? Okay, so there's my number line. Okay, so now I'm going to graph this one. So B is less than 0. So open or close circle on 0. Open. Less than. Shading to the right or to the left? To the left. Okay, next. B is greater than 8. Open or close circle? Open. Shading to the right or to the left? To the right, because it's greater than. Okay. So there's what my inequality looks like. Okay, are there questions on that one? On how we did that one? Any questions? Okay. All right. Let's go ahead. Let's take a look at number 3. Okay. So, number 3, it says you have this and you have this. Okay. So, when you have an and inequality, typically what it's going to graph like is well, you guys will see. Let's just do it and we'll see what happens. Okay. So, let's solve this inequality here and let's solve this one here. And we're going to put these on the number line. And when it says and, what that means is the solutions are these solutions and these solutions. So it's like what they have in common. Okay? So let's go ahead and how would we start graphing the first one? Or solving the first one? What would I get rid of first? The 9. Okay, so let's subtract the 9. What's 13? Take away 9. Is it 4? Okay, so x is less than or equal to 4. Okay, now let's go ahead and take a look at the next one. Okay, we're dividing by 5, so what's the opposite of dividing by 5? Okay, so we're going to multiply by 5 on both sides. So we get x is greater than -5. Now remember, the sign didn't need to change here because what kind of 5 did I multiply by? Wasn't it positive, so it doesn't need to change, okay? So now, we have, these are our solutions. X is less than or equal to 4, and x is greater than -5. So let's go ahead and graph that on a number line, see what happens, okay? I need my number line to go all the way from -5 at least to +4, okay? Okay, so did everyone go ahead and draw their number line? Okay, so let's go ahead and graph the first one. X is less than or equal to 4. So open or closed circle there? Closed. Okay, shading to the right or to the left? To the left. Okay, so it's going this way. Okay, now let's graph the next one. X is greater than -5. Open or closed circle on -5? Open. Greater than, shading to the right or to the left? To the right. So look what happens to these solutions. Do they start overlapping each other? Yeah, okay. So when you have the words and, what it means is and means the overlapping area is the solution. Okay, the points, the overlap are the points that are in common between this and this, so that's the solution, okay? When it says the word and, you're typically going to get something like the first one that we got up here, right? Where it was in between. The solutions are in between 2 points, because that's where the overlap is. Does that make sense? Okay. Now, what happened when we had or? Did it overlap when we had or? No, it was like going to be one solution or the other solution, but there wasn't any overlap, okay? So what do you guys predict your graph's going to look like on number 4? Yeah, probably 2 graphs going away from each other, right? Okay, so right now I want you guys to take a minute and try to see if you can solve and graph number 4. If you want, you can do it with a partner or you can do it on your own, but go ahead and try that one right now. Alright, so let's go over this one, okay? In this first one, what was your first step in solving? Subtract 8. Okay, so we're going to go ahead and subtract 8. Okay, we should get 9k is less than or equal to what? -36. Okay, what's after that? Divide by what? 9. Okay, so what was 36? -36 divided by 9. Alright. Okay, next. Let's go ahead and take a look at the next one. Okay, so what's our first step on the next one? Subtract 4. Okay, so we get 10k is greater than 70. Last step. Divide by 10. So we get k is greater than... Okay, now remember there's an or up there, so this is our full solution with the words. If you started with words in the original, make sure you put words in your solution. Okay, does that make sense? Like over here in the previous one, I put and there, right? In my solution. In this one up here, I put or. Okay, so if it starts with words, it has to end with words. If it doesn't start with words, like in number 1, you can just write your answer like that. Does that make sense? Okay, so look at the format of how it was given to you on how you should write your answer. Okay, now let's go ahead and graph. So I want my graph to go all the way from -4 at least to +7, right? Okay, so let's graph this one first. Open or closed circle? Closed. Shading says less than. To the right or to the left? To the left. Okay. All right, over here, open or closed circle on 7? Shading to the right or to the left? It says greater than. To the right. Okay, so does that make sense what we got there? So the solutions are either these points or these points. Okay? So, like a real life example of like when you would have maybe something like that is if I said like, I don't know, like there's an amusement park and it's designed for little kids, so it's like for children 6 and under. But they have to be accompanied by an adult, right? How old are adults? 18 and over, right? So the people at the amusement park are either 6 and under, or they are what? 18 and over, right? But their age can't be both of those things. Their age is either one or the other, right? Does that make sense? Okay. All right. Okay, let's take a look at some of the word problems here, okay? So, it says write a compound inequality to represent each situation, then graph. So what we're trying to do is we're trying to write a compound inequality and then graph it, okay? Let's take a look at problem number 5. Okay, it says the estimated amount of rainfall this week in Columbus, Ohio is a minimum of 4 inches and at most 7 inches. Okay, so what keyword do you see here? And. Okay, it's telling you minimum of 4 and at most 7.5. Okay, so we can either write our inequality with and with words like this, or we can write it like how we did in number 2, because I know number 2 and also can be written like this, right, where it's in between. Does that make sense? Okay, so which way would you guys like to write it? With words or like this? With words? Okay, so the first one says a minimum of 4 inches. Okay, so if there's going to be a minimum of 4 inches of rain, that's the smallest amount of rain there could be, right? Now, let's pick a variable to represent the amount of rain. So what variable do you guys want to use? R? Okay, so we're going to let R equal the amount of rainfall. Okay, and so in this situation, if the minimum amount is 4, R is going to be greater than, or could it equal 4? If 4 is the minimum, could it equal 4? Yeah, okay, so or equal to 4. And the at most 7.5 inches. So the rainfall, the most it can be is 7.5. So how would I write that as an inequality? R is, if the most number that the rainfall could be is 7.5, that's the highest number, right? Yeah, less than. Now, if it could be at most 7.5, could it be equal to 7.5? Yeah. Okay, so less than or equal to 7.5. Okay. All right, so now let's go ahead and graph this on a number line. Okay, I want to make sure that my number line at least includes the numbers that are on here. Okay, so let's graph the first one. R is greater than or equal to 4. So open or close circle. Closed. Shading to the right or to the left? To the right. Now I'm thinking since this is and, they're going to overlap. So where would my next dot go? 7.5. That's between 7 and 8, right? So I'm going to estimate. Open or close circle on that one? Closed. And it said the rainfall is at most 7.5, so under or less than or equal to 7.5, so that's going to go to the left. So that's the range of the rainfall, between 4 and 7.5, right? Including those endpoints. Does that make sense? Okay, let's take a look at the last one, number 6. Okay, number 6 says Julia is looking at prom dresses. Dresses start in price at $65, but she wants to spend under $100. Okay. All right, so what's kind of her price range she's looking at? Where do the dresses start and range at? They start where? At 65. Does she have like a limit that she wants to spend? Under 100. So does she want to actually spend 100? No, she wants to spend underneath 100, right? Okay, so let's write the first inequality. Could she buy a dress that's exactly 65? Is that okay with her? More than 65? Yeah. Okay, but it still has to be under how much? 100, right? So let's go ahead and choose a variable to represent the price of her dress. So what variable do you guys want to use? D? Okay, so let D equal the price of the dress. Okay, so the dress price can be greater than or equal to 65, right? It was okay if she spent 65. It was okay if she spent a little more than 65, right? And the dress price also needs to be what? Under 100. So the dress needs to be less than what? 100. Now, could it be equal to 100? What does it mean when it says under 100? Does she want to spend exactly 100? What does the word under mean? Below 100. So can I put an equal to on this one? No, because she doesn't want to spend 100. She wants to be under that price. Does that make sense? So we're not going to put an equal to on this one, okay? She wants to spend under, which means like 99.99, right? Or down. Does that make sense? Okay, so now let's go ahead and draw our number line, and we're going to graph. On my number line, maybe what would a good unit of measurement to make it count by be? Would I want to count my number line by ones? No. Maybe by like 5s or 10s, yeah? Okay, so I'll count mine by 5s. Okay, let's go ahead and graph the first inequality. So the first one says the dress price can be greater than or equal to 65. So let's go ahead and open or close circle on 65. Closed. Shading, to the right or to the left? Greater than, which way is greater than?
Right.
To the right. Okay. Now the second one says, and the dress must be under or less than 100. So open or close circle. Do we have a line here? No. So open circle. And then which way? Right or left? And remember, the solutions, because this is and, are all the values where these two inequalities overlap. Okay? So is $100 a solution? Is that a possible price she can spend on her dress? 100? She can spend exactly 100? No. She wanted to spend under 100, right? Can she spend 99? Yeah. Can she spend 65? Yes. Can she spend 60? No. Why? What were the dresses starting at?
65.
Yeah, so she can't spend 60. There's no dress for 60. Does that make sense? So the values that she can purchase are all in between here. Are we understanding what that's representing? Okay, here's what you guys are going to do next. You're going to write a summary, summarizing what you learned today. So quick little paragraph, few sentences, explaining what we learned about compound inequalities today in your own words. Okay, so that when you read back over your notes, you understand what it was, okay? And then you guys do have a homework tonight. It's the D3-Compound Inequalities homework. I'm going to post it on Google Classroom, okay? And you guys can start on that when you're done. Okay, any questions?